Now, from my understanding, photovoltaics only absorb energy from direct sunlight.
Right.
Are there any sort of developments working on looking at some of the other spectrums of light, like UV or even infrared?
Yeah, I think the PV only, you're right, only absorb a certain spectrum of the sunlight. But right now, there's a study, for example, by Stanford University and by some other laboratory that there's new technology that can not only the solar materials can not only absorb the certain spectrum of the sunbeam, but also collecting the thermal energy of the sun. So that combined strengths of harvesting energy from the sun can help reach to break through the efficiency from 30% to the 40% barrier. So that's going to be a significant step in the humanity's quest for energy from space. So that's going to happen. You're quite right, because energy from the sun, not just the energy from the light, but also from thermal radiation, and the radiation is actually from a lot of wide spectrum of sun's radiation that you won't even actually see them, and so you're right. The way to increase efficiency of the solar panel is a breakthrough in the material technology. I think we have seen a lot of most recent very encouraging development in that aspect.
Good. What would be your preferred method of transport of beaming the energy back to Earth?
That's a very good question. Actually, it's been a lot of debate because I was on a working group of IAA. We just had a meeting most recent at ESA headquarters in Paris in March. It was IAA means International Astronautical Academy. So now we have formal support, strong support from IAA. And that's why we had this working group meeting. There's not a debate at the meeting whether or not we should select the way of utilizing radio wave, basically the form of a microwave, to beam back energy, or we should utilize the laser beam. So I think this is a system trade-off study question, because when I was in NASA, being on the lunar surface program, the constellation program, the space shuttle program, what we do in risk assessments, we do a lot of we call the trade-off study, system study. Trade-off means you have a different technology, you have a different way of achieving certain kind of engineering objective, but how you have to do a systematic study. Build the mathematical models and actually do the cost analysis, engineering risk assessment, and all kinds of study to come up with a conclusion or recommendation which one is better. So it's a very complicated question to answer, but as far as I can tell, each technology between microwave transmission and laser beam transmission have their own advantage and disadvantage. For example, the microwave transmission does not and susceptible to the weather condition. For example, you have a cloud cover day or very rainy days, because the penetration capability of a penetration through the bad weather condition is much better than laser beam. Because laser beam also have a higher efficiency and in terms of energy intensity, but it is very susceptible to weather condition, and it can, if you have a laser beam, you hit something, you hit a very dense cloud, it can beam right back. So you lost efficiency. So it depends on application. For example, for small disaster area that desperately need power, some natural disaster strike, a tsunami or earthquake area, you can utilize it, but you need the reaction very quickly. deployment rapidly of some power in certain parts of the area on Earth, I think the laser beam has a lot of advantage because very easily steering the beam in terms of the targeted area you wanted to help. But I mean, some people have safety concerns on the laser transmission, energy transmission, because although there's the infrared laser beam that we can take, from technology perspective, we can avoid this kind of risk to damage lives and animals and anything on Earth that don't want to damage. But the perceived risk, the risk perception in the general public is quite high, because of course the laser. But there's lots of different kind of laser, but some laser you can utilize even as a weapon, right? And so it can destroy satellites, it can destroy any target on Earth. So when the general public heard the first, the first name of laser, they would perceive the very high risk, and they were worried about their safety. They think, well, maybe people were utilizing the laser transmission as a weapon to destroy each other. So that's kind of a social political risk perception that we have to overcome to convince people, educate people. Actually, there's a technological way to avoid that. But a radio wave, microwave transmission, you need a very large antenna, the transmitting antenna, not only on space but on the ground, because the energy density is very low, and it has, of course, much better capability to penetrate in bad weather. It's proven technology. The NASA 1975 Goldstone demonstration, if you heard about it, and it actually achieved, my friend Dick Dickinson was one of the key management on that demonstration team, achieved 34 kilowatt power transmission back in 1975. So microwave transmission, I think for utility scale, for large scale, we talk about gigawatt scale solar power satellite. It has a tremendous advantage over the laser. But for leaky market, or for leach market, for disaster area relief, and for rapid deployment of solar power, I think laser has its advantage. So it's a hard question to answer, but it will be answered in a systematic system demonstration study. That's what we're trying to do right now. The European actually, some European experts believe more on laser technology, but I think a lot of Americans, me included as well, I think we basically have to utilize it in a different markets, and you cannot just say abandoning this technology and in favor of a different technology. It's just different application.